Okay, today we're going to start our chapter on polynomials. Okay, so what are polynomials? They're expressions with positive or zero whole numbers for the exponents that are combined via addition and subtraction. That's only my definition. It's probably not the exact definition, but we'll just do a little example. When you see the example, you'll know what the go is. So you might have a function f of x equals x to the 4 plus 2x cubed minus 6x squared plus 13x minus 7. For example, here we've got a quartic, so it's a quartic polynomial. If we only had the, it's of degree 4 because this is the highest power. So with the highest power, we call it degree 4, and then we've got all the other powers along there. That's it. That's what polynomials are. That's what they look like. And let's start with some of our favorite polynomials, our quadratic polynomials. Okay, so here we go. So we know quadratic polynomials make parabolas, okay? And we have transformation of those parabolas. And we'll just draw a real quick graph here. Just do a quick sketch. So if we have the function y equals x squared, we might get something like this, okay? And if we have ax squared, then it might, if a is greater than 1, we're going to get a skinnier graph because it's going to get stretched up. So stretched up this way, away from the x-axis. Or if we have between 0 and 1, we might have a flatter parabola. Okay, that's much flatter along like that. So that could be y equals half x squared, for example. We'll give you that one. All right. We can also, if we've got a negative here for a, we can reflect it, okay, in the x-axis. Okay, so that obviously is going to look something along those lines, which I like to call the sad face. This is the happy face, which, I call this the upright parabola, and this is the upside down parabola. So if I ever refer to the upside down parabola, I mean reflected in the x-axis. And then translated. Okay, so here we've got translated, so this is moved to the right h and up k. So in this case, to the right h if h is positive number, and up k. Okay, and that's it for transformations of quadratics. Okay, here we go. We were just looking at this just then. The turning point form. Okay, so lots of different ways we can write our quadratics. So this is turning point form. So what can we tell from this? Straight off, we can tell whether it's a happy face, an upright parabola, or an upside down parabola, just by looking at whether a is a positive number or a negative number. So if it's a positive number, we get this one. If it's a negative number, we get this one. Okay, and then we can also tell the turning point here, h and k. So we know that the turning point is h. Okay, and we also get the line of symmetry. Okay, so the line of symmetry is going to be x is equal to whatever h is. Obviously, because the turning point, it's symmetrical about the turning point. So as long as you know that x-axis, or the x ordinate, or the coordinate for the turning point, then you know the line of symmetry. Okay, another form, y-intercept form. Just your standard ax squared plus bx plus c. Okay, so this is a really great form if you know, because you can tell the y-intercept is 0, c. So whatever that is our y-intercept. We can also look at the value of a, and if it's positive, then we've got an upright parabola, and if it's upside down, we've got a negative a, then it's going to be upside down. Okay, so how do we get from one form to the other? So if we're in this form and we think, well, we don't get to know much in this form, we only get to know really the y-intercept, can we turn it into turning point form? The answer is yes, we can complete the square. So let's complete the square on this one here. So what do I get? Firstly, I'm going to take out the a as a common factor of everything. So I'm going to get b on a, x plus c on a, like that, okay? And then I'm going to do my complete the square just on this bit. So what am I going to get? I'm going to get, can I do this all in one go? Yeah, sure. Okay, so in the bracket, okay, so I'm going to make this the squared, yeah? And so I'm just going to have the square root of this one, which is just x, and then I'm going to, the second term is going to be half of this. So it's going to be b over a, okay, or b over 2a, sorry. Half of that, b over 2a, okay? And then I'm going to add on the square of this. So I'm going to add on b squared over 4a squared, okay? But I've done that to get this, so I'm going to minus it away again, sorry. Minus it away, and then I've still got the c over a here, okay? Let me just check and make sure I've got that right. I think I have, okay. And then, okay, so I've still got this, x plus b over 2a, all squared. I'm just going to put this over common denominator here. So I want an times by 4 and multiply by another a. So I'm getting it minus b squared plus 4ac, now this is looking familiar, over 4a squared, like that. Okay, and then I can expand it out. So I expand this a back out, so I get a x plus b over 2a squared minus b squared minus 4ac over 4a. Okay, not a squared anymore because I multiplied both terms by a, so one of the a's disappeared, and I end up with the turning point form. So now I can see that our line of symmetry, okay, so line of symmetry, I've got equals x equals minus b over 2a, okay, and I can tell the turning point is minus b over 2a, and also let's move down, minus b squared minus 4ac over 4a, okay, and I've got the turning point now. Okay, so from this I could use these coefficients to get the turning point, which is quite nice. Yeah, might need to write a Michael function on the CAS to find out for me. Okay, so we'll pick up where we left off and we'll change it into x-intercept form. So if I want the x-intercepts, okay, so I started with this, the turning point form. Okay, I've still got the a taken out, and then I can put these together, right? So using the difference of two squares, and I get x plus b over 2a minus the b squared, minus the square root of b squared minus 4ac. The square root of 4a squared is 2a. Okay, there's one bracket. And then I've got x plus b over 2a. Instead of minus, we'll go plus, because this is the difference of two squares. You go minus this and plus this. Okay, square root b squared minus 4ac over 2a. And there we go. And you know, you can see that this is literally the quadratic formula. Okay, so I've got x plus b minus square root b squared minus 4ac over 2a, and x plus b plus the square root of b squared minus 4ac over 2a. Wonderful. Cool. All right, so this tells me my x-intercepts are, okay, what do I get? I get negative b minus b squared minus 4ac under square root over 2a naught, and negative b plus the square root of b squared minus 4ac over 2a naught. Excellent. So you get all of that. Let me just turn the page. Yep. And obviously our axes of symmetry, let's look at our axis of symmetry here, right? Negative b over 2a. Okay, negative b over 2a, our axis of symmetry. So we can tell that our whole parabola is symmetrical here, yeah? Because our x-intercepts are going to lie the same distance from our axis of symmetry, okay? So it's going to, you start with the axis of symmetry here. So this is where the turning point is at negative b on 2a. And then you're minusing away this bit. And then you're adding that bit on, same thing, okay? So it tells you that from your axis of symmetry, your x-intercepts lie the same distance from that, okay? Which makes sense, it's all symmetrical. Parabolas are symmetrical about that line. Okay, let's get rid of that. And we're up to an example. Okay, let's have a look at that example. Okay, so what can we tell from this one? We've got a function, what can we find? Can we find the turning point, the x-intercepts, the y-intercept? What else? Okay, I think that's it. Just having a look to see why I put that one there. I have no idea. Okay, that's all right. Don't worry about it. Let's just see what happens. Okay, so from this, we're in y-intercept form. So we should be able to tell the y-intercept just by inspection. What is it? Of course, it is c. Yeah, so 0, 6. Okay, wonderful. What else can we tell? I'm not sure. Okay, so we could use the formulas that we came up with to try and work out the turning point. Okay, so let's do that. Oh, we know it's the right way up too, because this is a positive number. So upright, I think that's what I meant to write. Upright parabola. There we go, that's why I put that there. Okay, so can we find the turning point? So we've got the turning point. We know that that has to be at b over 2a, bracket, minus b squared, minus, okay, so it's minus b squared minus 4ac over 4a. Okay, so this, it's minus all of this. Okay, so we can put those values in. Okay, so what do we get here? B over 2a. So b is negative 7 over 2a. So 2 times 2 is 4. Okay, we got that one. Minus b squared minus 4ac. So let's just do that over here. B squared, and we call that the discriminant, don't we? B squared minus 4ac. Okay, so what's that? B squared is 49 minus 4 times 2 times 6. Okay, so I'll go 49 minus 48, which equals 1. Okay, so that's just 1. Negative 1 over 4a. So 4 times 2 is 8. There we go, we've got the turning point. Wonderful. Negative 1, 8. Now, did I make a mistake? I think that's right. I'm just making sure. Yep, negative there, that seems to be right. Okay, I think I just made a mistake in my notes. All right, the x-intercepts. X-intercepts are when x equals negative b plus or minus square root b squared minus 4ac, formula you're all very familiar with, over 2a. Okay, let's put it in. So negative b, I get 7 plus or minus square root 1 over 4. Okay, so that's 8 over 4. Now 8 over 4 is 2, or 6 over 4 is the same as 3 over 2. Okay, so these are the x-intercepts. Of course, in a methods exam, we're always going to write them as coordinates. We're never going to leave them as just single figures. Okay, that's it. Perfect. So that was really easy to get all the information out of there as long as you know what these formulas are. Okay, wonderful. Next, the discriminant. We talked about the discriminant. I'm just going to flip my notes over. Okay, the discriminant. B squared minus 4ac. This is just a bit of a reminder what it tells us. If the discriminant is less than 0. Okay, so this is under the square root sign in the quadratic formula. So therefore, if it's negative under the square root sign, we're not going to get any real solutions. So that tells us our parabola is sitting either above the x-axis, or it could be upside down and below the x-axis. But what it tells us is it doesn't cross the x-axis at any stage. Okay, so I'll just write that in. I'll say no x-intercepts. Yeah, no x-intercepts. Okay, that's what it tells us. All right. Also, you're not going to be able to factor into linear factors. Okay, so no linear real factors. Okay, there we go. What if the discriminant is equal to 0? If it's equal to 0, then you've got your parabola sitting on the axis at a particular point, so there's only one x-intercept. Okay, now it could be upside down, that's fine, but it only touches the x-intercept. Okay, so one x-intercept, and where is that? Obviously it has to be on the turning point, which we know is at b on 2a, negative b on 2a. Okay, so that's really easy to find. Next one, if it is greater than 0. Okay, so if you've got a discriminant greater than 0, you have two x-intercepts. Okay, so I'll draw a little graph of that. But you can also tell a lot about those two x-intercepts. Okay, and what you can do if you can factorize. So there's two situations. Is the discriminant a perfect square? That is like 1, 4, 9, 16, 25. So can you take the square root of this number and get a whole number out? If that's true, then you've got rational factors, okay, which means you can do it, you can use grouping. Okay, that's what it comes down to. You can use grouping to factorize. Wonderful. That's wonderful. That's good news. You don't need to complete the square. Okay, and you have rational solutions. Okay, so rational x-intercepts. Right. However, if it's not a perfect square, then you end up with the situation where you have to complete the square if you want to factorize. Complete the square. Or you can use the quadratic formula to find the solutions. Okay, you can do either of those, that's fine. Okay, but you only have to do that if it's not a perfect square, otherwise there's a shortcut. If it is a perfect square, shortcut method. Okay, wonderful. All right, now we're going to talk about, so that was only 4a right there. Okay, so now we're up to chapter 4b, but now it'll become a bit quicker. Okay, so if you're trying to find the rule and you're given 3 random points, okay, so you're just given 3 points that the parabola goes through, okay, then what you do is you use y equals ax squared plus bx plus c, and you substitute all those points in, and you end up with 3 equations with a, b, and c in it, and you solve for that simultaneously. So you use simultaneous equations to solve those 3 simultaneous equations. Okay. Now most of the time, either they'll come out nice and easy for you to do if you have to do it by hand, otherwise you're going to be expected to do that on your CAS. Okay. If given a turning point and one other point, okay, so given the turning point, So if you know one of the points is a turning point and you give them one other point on the graph, so you use y equals x minus h squared plus k. Okay, so you plug those points into this formula because you know what the turning point is, so you automatically get h and k for free, and then you just use the other point to solve for a. Much easier situation, okay? So that's the form you use if you're given those things. If you're given the x-intercept and one other point, both the x-intercepts, so you can use y equals a and use the intersect form. Okay, I'm just going to use minus b and x minus c. Okay, now these a and b's are different to these ones. Okay, so you put in the x-intercepts in for b and c, and again you solve for a. Okay, I mean that's pretty straightforward. Okay, there is one thing I want to show you about this chapter, and that's equating coefficients. A really handy way of factoring and doing all sorts of things. Okay, so it's a really cool technique to use. Okay, so let's pretend we've got this cubic here. Okay, okay, so this is from 4C. We've got this cubic, and we want to find one of its factors and try and factorize it. Okay, so we're going to look for, I look at factors of 15 first because it's going to be a factor of 15 in order for it to factorize. Okay, so let's just use 1 because 1 is easy. Okay, so f of 1, so let's have a look at that. F of 1, I get 2 times 1, so I just look at the coefficients here. 2 plus 11 plus, that's 15, minus 15 is 0. Perfect. That's what I'm looking for. Therefore, I know that x minus 1 is a factor. Okay, so 1's a good one to look at. If I didn't get 1, maybe I'd choose negative 1. Try and see if that one's a factor as well. Okay, so I know that's a factor. So what I could do is I could do my long division now, right? So I could do my long division, but I'm going to do it using this equating coefficients method instead. It's like a quick way to sort of figure out what my quadratic is. So I know I'm going to have, I'll write it out in full, sorry, 2x cubed plus 11x squared plus 2x minus 15. I'm just writing it out in full so you can see. So then I'm going to factorize that to x minus 1 times x squared plus, well, I'll go ax squared plus bx plus c, like that. Okay. Now, if I was to expand this out here, I get ax cubed, and then I look for my x squared. So how do I get an x squared? I get that, bx minus a, so I get plus b minus a x squared. How do I get my x's? I get x times c minus b plus c minus b x, and then minus c. Okay, so I can look straight away and say, well, my coefficient of x cubed is a, and my coefficients of x cubed here is 2. So they've got to be equal to each other. Therefore, a is equal to 2. Okay, I could do the same with c down here. Negative c has to equal negative 15. Therefore, c is negative 15. Excellent. So I've only got to work out what b is. So b, if I look at my 11, has to equal the coefficient of x squared. So look at the x squareds, look at the coefficients, equate them. So I've got 11 has to equal b minus a. But I know what a is. A is already 2. So 11 is b minus 2. Okay, therefore b is equal to 13. Okay, so I've done the division without doing the division. Okay, so now I've got x minus 1 multiplied by a, which is 2x squared, yeah, plus b plus 13x minus 15. And there we go. And then I can factorize this to get the rest of my factors. Okay, if there are any, yep, there would be. So I could factorize that by grouping if I needed to. Okay. All right. So that's a cool technique. Now, just so everyone remembers, we'll do the same question again, and we'll do polynomial division. Okay. So here's the same thing before. We'll make sure we get the same answer by polynomial division. Okay. So just as a reminder, this is how we do polynomial division. We write it all out. 11x squared, plus 2x minus 15. Okay. So how do we do this? We go, how many times does x go into this one? So it goes in 2x squared times. So then you go 2x squared minus times x, 2x cubed, 2x squared times negative 1, negative 2x squared, and then I minus it all away. So I should get 0 here, which is perfect. And then I get 11 minus 2 plus 13x squared plus 2x minus 15. Okay. And then I start the whole process again. X goes into this plus 13x times x, 13x squared, 13x times negative 1, negative 13x. Let's see if it works. Take it all away. I get 0x squared, which is perfect. And then minus this, I get plus 15x. Okay. Minus 15. Cool. X goes into this 15 times. So I get 15 times x is 15x. And 15 times negative 1 is minus 15. When I minus it all away, I get 0x plus 0. Perfect. So I know that this is a perfect factor because I have no remainder. And this is what I had before. Yeah. 2x squared minus that. And have I done it wrong? I don't think so. I think that's right. No, I should have got minus 15, shouldn't I? Where did I bug that up? Let me just make sure. No, hang on. My C in my original question should have been... No. Yeah. Oops. Yeah, I marked that up in my original question. It was plus 15. I've got it right now. Okay. So there was a little mistake in the quite before. I'll go back to it. I'll fix it. I'll fix it in the edit. Here we go. So this should have been, because I've got C, negative C is equal to negative 15, therefore C is positive 15. That's a positive there. Okay. So I marked that up a little bit. Anyway, it's fixed now. So there you go. So maybe it is better to do this. Might not make a silly mistake. All right. There is a cheap way to do it though. So this is proper polynomial division. There's sneaky division, which is not really called sneaky division. It's just what I call it. Okay. I think it actually, people call it synthetic division. Okay. So instead of doing all this, we can basically do it all in one line. Okay. So we're going to divide 1. Okay. So my factor x minus 1. So I solve that for 0 and I get 1. And then I just write the coefficients down. 2, 11, 2, and negative 15. Okay, the coefficients down. So shorten the whole process. Put a 0 here. Always put a 0 here. And then you just add up downwards. So 2 plus 0 is 2. 2 times 1 is 2. I add 13. 13 times 1 is 13. I add, makes it 15. 15 times 1 is 15. I add and get 0. So this is the remainder. And these are the coefficients of my new one. 2x cubed plus 13x plus 15. Perfect. Okay, so that's a really quick way if you're doing it by an easy linear factor. Okay. Oops. Drop my pen. As usual. Okay. Couple more things. What have I got down here? I'll do it on this one. Okay. A couple of things that you should know about cubics. Okay. When you've got the difference of two squares. Okay, so we'll do two squares. You know that if you've got x squared minus a squared, then it factors to x minus a, x plus a. We used that before. Okay, difference of two cubes. So if you've got x cubed minus a cubed, then that becomes x minus a, x squared plus ax plus a squared. Okay, and if you've got the difference of, oh, not difference, sum. The sum of two cubes, so x cubed plus a cubed, that equals x plus a, x squared minus ax plus a squared. Okay, that's it. You just got to know those formulas just like you do for the difference of two squares, and you can factorize those. Okay. Let's keep going. I'll add the pen drop to the board if you find it. Okay. 4e. Okay, we're up to 4e. Cubic functions. Okay, so we've got a few different shapes here for cubic functions. What can they look like? All right, we can look like this. This is just like your classic y equals x cubed, where you've got a stationary point here, which means the gradient is 0 at this point. We'll do more about that when we get to calculus, but that's just goes all the way down around to perfectly flat there, and then it's because it's a point of inflection, goes back up the other way. Okay, and then up and down, you've got the ones where you've got turning points like this. So you've got two turning points. You've got this local maximum up here, so you've got a hill, and then you've got a crest down here, or a local minimum down here, the turning point down there. The other one you could sort of have is where it doesn't quite go to a stationary point. Okay, so still a point of inflection, but it doesn't go all the way flat. Okay, I don't know if I've drawn that very well. There we go, that'll do. Okay, so it doesn't. You can have that for the cubic as well. All right, some things to know about. All right, here's an example. We've got this example. It's kind of similar to the other one. Now, for our factors, okay, this is called the rational root theorem. If you've got a rational root, then this beta is going to be a factor of the first coefficient, or the coefficient of the highest degree bit. I don't know what you call that. The cubed in this case. And the alpha is going to be a factor of the last one down here. Okay, so they're the ones you're checking for if you're looking for roots. Okay, should we look for 1 again? Let's look for 1. So if I go look for f equals 1, what do I get? I get 2, minus 9 is minus 7, minus 15 plus 15 is 0. Geez, I've worked that nicely, haven't I? That f of 1 seems to work. You might not be quite as lucky, but I'm going to do my synthetic division because it's quick and easy, less likely to make an error. Okay, so I put a 0 here, just so you haven't, watch this, 2 plus 0 is 2, 2 times 1 is 2, negative 9 plus 2 is negative 7, negative 7 times 1 is negative 7, negative 8 minus 7, negative 15, 15 times 1 is negative 15, 15 that's 0. Okay, perfect. So there's my coefficients of my quadratic. So that was easy. So I've got x minus 1, 2x squared minus 7x minus 15. Okay, and okay, so we're going to group this one. Okay, so 2x squared, how are we going to group this? We're going to go, that multiplies to 30, so if we go minus 10x plus 3x minus 15, okay, we'll group, take out common factors, 2x, x minus 5, take out 3, x minus 5, therefore I get 2x plus 3 is on the outside, and x minus 5 on the inside. Perfect. And then obviously I've got my last one there. So now I've got all the factors of my cubic. Wonderful. Was that all I wanted to do with that? Okay, so if you want to sketch this, I'll just sketch it down here. Apparently I wanted to do a bit more than just factorize it. I wanted to get what it looked like. Okay, so we know the x-intercepts now, and we know the y-intercept. So the y-intercept is 15. Okay, so the y-intercept is up here at 15, and we've got x equals 1, we've got x equals 5, we've got x equals negative 1.5, which is there. And do I need to know anything else? Do I need to make a sign diagram to try and work out which way it is? No, I don't, because I know which way it is. I know that this is a positive number, so it's going to be an upright cubic. So I need to know the upright cubic. So I know it goes up like this. And go, well, it goes up like this, goes down like this, and then it turns like this. Okay. Now it might turn a little bit before, doesn't necessarily turn at the y-intercept, which is probably false, so I might make it turn like that. And I might put the coordinates in, 1, 0, 5, 0, negative 3 on 2, 0, and my y-intercept at 0, 15. Perfect. Done. Okay. So we've done quadratics, we've done some cubics. Can we do some quartics? Okay, some higher degree polynomials. So, how am I going to do this one? I'm going to look for factors of 90 here that hopefully are going to add up. Now, if I try f equals, or g of 1, so try g of 1, guess what? It doesn't work. Okay, so I've got 4 plus 24 is 28, 30, whatever that is, and then I'm going to end up with way wrong. Okay, so that's no good. Don't want that. Let's try f of 2 maybe. Okay, oh, g of 2. So g of 2, I get 4 to the 4 plus 24 2 cubed plus 5 2 squared minus 93 to the 2 minus 90. You might think, geez, that's a bit hard to do by hand, but powers of 2 are pretty good. So 4 times 16. So 4 times anything, just double it twice. So I get 32, 64. So it's going to be 64. 2 cubed is 8. And then 8 times 24. So I want to double it 3 times. So I want to double 24 3 times. So 24, 48, 96. And last time, what's that? 96, what's that? 192. Okay. And then 2 squared is 4, 4 5s are 20. And then 93 times 2 is 186 minus 90. Okay. Let's see if we can put these together. What do I get when I put these together? Okay. Alright, so 192 minus 186. Okay, that's just 6. So we've got 64 plus 6 plus 20 minus 90. That's now it's pretty easy, yeah? Now I get 70 plus 20 minus 90. So I get 90 minus 90 equals 0. Perfect. Okay. So g of 2, well, that tells me x minus 2 is a factor. Okay. Now I could try and go for another factor, but this is pretty long, and I know synthetic division is really quick, so it might be easier if I get it down to the cubic. Okay, so let's get it down to the cubic. So 4, 24, 5, 93, 90. Put a 0 here. Let's add it up. So 4 plus 0 is 4. 4 2s are 8. 8 plus 24 is 32. 32 times 2 is 64. 5 plus 64 is 69. 69 times 2 these days is 138, I think. I got 138, okay. Oh, it's minus 93, so don't muck that up. Minus 93. The difference between 138 and 93 is 45, I think. 45 times 2 is 90. Yeah, of course it is. There we go. Add it up. 0 gives me confidence that I got the right answer. They're my coefficients of my cubic. Okay, so now I've got here 4x cubed plus 32x squared plus 69x plus 45. Good. Okay. There's that. Okay, so now I'm looking at factors of 45 that are going to... I know 1 doesn't work. I've already tried 1, so that's no good. Let's try 5. 5's a pretty small factor. So g of 5 is that going to give me 0? So that gives me, well, if I'm going to do this properly, g of 5, don't just call this g. 5 minus 2 is 3. And then I've just got to make sure this one is 0. So 4 times 5 cubed, 32 5 squared, 69 times 5 plus 45. Okay. So that gives me 3 by 5 cubed is 125. So 250, okay, so that's all right. 25 times 32. I'm going to do 25 times 32. Okay, so I'll times it by 5 twice, basically. So times it by 5 is times it by 10 and then halving it. Okay, so 320, so 160 is times by 5, and then 160 times by 10 is 1600. Half that is 800. Cool. 69 times 5, so 69 times 10 is 690. Half of 690 is 345 plus 45. Now, did I miss a negative somewhere? Because all these numbers are positive and none of them is 0, so that did not work. What if we get negative 5? So that makes that a 7. Okay, so we've got negative 7 times, this is negative 5, we get negative 500. Now this stays positive. This becomes negative, so we get negative 345 plus 45. What do I get there? Oh yeah, because that's 300 there. Oh, perfect. Okay, so I get minus 300 minus 500 is not, yeah, perfect. So I get negative 7 times 0, which is 0. Okay, so we've got another factor now. That was a bit easier than putting negative 5 into this one, which might have been a bit tricky. So getting it down to the cubic makes the numbers a bit smaller, makes it a bit easier to do. All right, so what have I got so far? I've got the factors x minus 2, x plus 5, and then I'm going to be left with, I suppose I better do the polynomial division again. Okay, so let's do the division over here. So negative 5, bracket, what have I got? 4, 32, 69, 45, put a 0 down. Okay, what do I get? I get 4, negative 20 is 12, 12 is negative 60 is 9, 9 negative 45, perfect, 0. Then I've got 4x squared plus 12x plus 9. Excellent. This I can factorize, I think. Yep, 6 6s are 36 and 4 9s are 36. So I get, what do I get? I get 4x squared plus 6x plus 6x plus 9. Take out 2x squared, 2x, bracket 2x plus 3. And then I get, take out 3x plus 3. Sorry, 2x plus 3. So 2x plus 3, 2x plus 3. This is a perfect square, sorry. So I get x minus 2, x plus 5, 2x plus 3 all squared. Okay, so this is my function of g of x. Okay, so this squared tells me I've got a turning point on the axis, sitting on the axis at -3 on, or -1.5. And then these are two other x-intercepts. So if I just sketch that, I'll just do it here. Yep, I don't have any room on the next slide to do this, so that's good. Going to the slides, next whiteboard. Okay, so what have I got? I got x equals 2. Put that there. I've got x equals -5 there, and x equals -1.5 there. So I know it's a upright quartic. So that means it's going to start up here. It's going to go down through here, and it's going to turn at this one. It's going to go down through here, turn and come back up, go this way. So this is -5 naught, -3 on 2 naught, 2 naught, and the y-intercept at -90. So we'll put this one at 0, -90. Done. There's my sketch graph. Perfect. All right. Determining the rule. Now, I've got a bunch of points, and it says these points lie on a quartic polynomial. What is the rule for the quartic? You might be thinking this is impossible. And it's not impossible in this case. We've got to look for clues though. Got to look for clues. What are these points? What's special about them? Okay, so this one is an x-intercept. Perfect. Xint. That's a huge clue. This one, yint. Perfect. Another huge clue. Another x-intercept. Perfect. This one, just a random point. This one, just another random point. But these are special. Okay, so if I said the quartic was, now let's write this out, y equals ax to the 4 plus bx to the cube plus cx squared plus dx plus e. Okay, well, we know what e is. We've got e down pat. Therefore, e is equal to 6. Yint. Done. Perfect. Okay, so we've got that down pat. However, that's still a bit tricky to solve, so that hasn't really helped us much. So let's draw a line in the sand there, and we'll go with the x-intercepts. Might be a bit more useful. So I know, what do I know? I know x plus 3 is a factor. Cool. I know x minus 1 is a factor from here. And I know, what am I left with? I'm left with ax squared plus bx plus c. Okay. And then I've got this point, and this point to deal with that. Now, the good thing about this is I can work out what c is by doing the same thing I did up here. Yeah. So I put in 0. If I put in 0, I get 3 times -1 times c. So I've got -3 times c has to equal 6. Therefore, 6 is c is -2. So now I've got this bit, because I've got a whiteboard, just put that in, -2. Wonderful. Okay, so now I've got that. I just need to find b and a. Okay, so I can put my other 2 points in and find 2 equations to solve. Okay, so let's put this one in, -1. So I get 12 equals -1. I get 2 times negative 2 times a, negative 1 squared, times a, minus b, minus 2. Okay, so I get 12. Well, 12 divided by negative 4 is negative 3. So I get negative 3 equals a minus b minus 2. So I can add the 2 on, get negative 1. So I get negative 1 equals a minus b. Okay, that's my equation 1. Now I can do that because I have a whiteboard. You might have to write extra lines. That's fine. Just do it. Okay, equation number 2. Do it in green. Do the same thing. Put in 2. So I've got 60 equals, and I'm going to put in 2. So I get 5 times 4 times 2 squared. So I get 4a plus 2b minus 2. Okay, 60 divided by 20 is 3 equals 3 plus 2 is 5 equals 4a plus 2b. That is not what I have on my working out. What have I done wrong here? Oh, I know what I've done wrong. Well, how did I get that? I put 5 in there to get that. Okay, well, I should have been putting in 2. 2 minus 1 is 1. So that becomes 5, it's 12. 12 plus 2 is 14. That should be 14. And then I get the right answer. Cool. Okay, so don't make that mistake. Divided by 2, I get 7. 2a plus b. Okay, there we go, equation 2. Always worthwhile doing your answers before doing the video. Okay, so hopefully that's okay now. And we've just got these two simultaneous equations to solve. Okay, so let's go let's take this equation. A is equal to b minus 1. And then I'll put it into this equation. So we get 7 equals twice b minus 1 plus b. So we get 2b minus b minus 2 plus b. So we get 3b. 7 plus 2 is 9. Therefore, b is equal to 3. Hopefully that's right. And then I know that a is 1 less than b. So it's 2. Okay, so there we go. We can put that in. Y equals x plus 3, x minus 1. I've got 2x squared. 2x squared plus 3bx minus 2. Can I, oh sorry, not 3bx, 3x. 3x minus 2. Can I factorize that? Negative 4. So 4 minus 1. So I'll just do 2x squared plus, oops, just get plus 4x minus x minus 2. Group. Take out 2x as common, x plus 2. Take out negative 1, I get x plus 2. Therefore, this is going to be x plus 3, x minus 1. I get 2x minus 1 and x plus 2. Okay, now you've got all that. You could sketch it if you want, but that'll do. That's the rule. That's it factorized. Whew, we're almost there. Almost through another video. Okay. Only 2 panels to go, and I don't think they're too hard. Only 1 sheet of paper left. Excellent. Okay, so how would we solve this sort of literal type equation? It's got some letters in here. How do we solve this one? Okay, so it's got a common factor of x, so let's take out the x. So I get x squared plus 4ax plus 4a squared equals 0. Okay, and then you could group it or factorize it. Okay, so because this one is actually x plus 2a times x plus 2a. Okay, so if I look at that, I get x squared, I get 2ax plus another 2ax equals 4ax, and then 2a times 2a is 4a squared equals 0. Therefore x equals 0, or x equals 2a if you have to find the solutions there. That's done. Piece of cake. Alright, last one. Excellent. Find the points of intersection of these two lines, or these two curves. So I've got a parabola and a line. So we want to find when they intersect each other, so when they're equal to each other. So we just set them equal to each other. 3x squared minus 12x plus 11 is equal to 2x plus 3. Okay. You put all this on this side, so I get 3x squared minus 14x, negative 12x minus 2x, 11 minus 3 is plus 8, equals 0. Okay, can we group it? Let's give it a go. So 3x squared, I want this to be minus 12x, plus minus 2x plus 8. Okay, so those two add up to this, but they multiply together to give 3 times 8, which is 24, and 12 times 2 is 24, so that's good. Okay, take out the common factors, so 3x, leaves me with x minus 4, take out the 2, x minus 4, or negative 2, gives me 3x minus 2 on the outside, x minus 4 inside, and we're looking for when this is all equal to 0. Equal to 0, so that means they intersect at x equals 2 and 3 and x equals 4. Now that's the hard bit. You can put that into one of these equations, each of these. Now let's pick the linear one because that's much easier to do. So let's find what y equals. So when I put in 4, I get 2 times 4 plus 3 is 11. Okay, so I've got 4, 11 is 1 point. And when I put in 2/3, I get y equals 4/3 plus 3, which is 13/3. So my other point is 2/3 and 13/3. Cool. That's it for this video. That's all of chapter 4. Well done.